This is the first lesson of a kinematics playlist that I'm creating. So I'm going to quickly explain what kinematics is before moving on to the video. Kinematics is a branch of physics that describes how things move without worrying about the forces causing that motion. In kinematics, reference frames and displacement are foundational topics that you can't skip. It'll build up to more advanced topics later on like velocity and acceleration. In physics, you have to understand that any measurement of position, speed, or distance is made with respect to a frame of reference. Let's say we have a train. Here's our beautiful train. Here's his wheels. Here's his window. He's moving forward relative to the ground at 80 kilometers an hour. If somebody on the train, so a human on the train, walks forward toward the front of the train at 5 kilometers an hour, relative to the train, he's moving at 5 kilometers an hour. But relative to the ground, he's moving at 85 kilometers an hour. Because the train speed is also taken into account. I'll say that again. Relative to the train, he's walking at 5 kilometers an hour. But relative to the ground, he's moving at 85 kilometers an hour. He's moving with the train. In everyday life, we speak in the reference frame of Earth. Let's take our same beautiful train that we have created. Now he is driving forward on the ground at 100 kilometers an hour. Someone inside the train, so this guy here, he decides to throw a ball up and down. So straight up and straight down into his hand. From an outside observer, what does he see? I'll give you a second to think. He is going to see the ball move in this kind of path. A curved path. Because the ball is moving forward with the train from his perspective. But from the man on the train, he just sees the ball going straight up and down. So the important thing to remember is that motion depends on the observer's frame of reference. Moving on to displacement. Displacement and distance are not the same. You must understand this. I'll give you an example. Let's draw up a quick coordinate thing because in physics we like to do that. You decide to go on a walk and you walk 50 meters north. Then you turn around and you walk 20 meters south. The total distance you've traveled, so distance traveled is 70 meters. 50 meters plus 20 meters, 70 meters. However, your displacement is 30 meters. Because the definition of displacement is how far you are from your starting position. You're 30 meters north from your starting point. So displacement is a quantity with magnitude and direction. Magnitude being 30 meters here and direction being north. We call these vectors. Vectors are quantities with magnitude and direction. Now you might have learned about vectors in math. If you haven't, it's okay. In diagrams, they're represented by arrows. So our displacement vector, here we will draw it like this on the graph. In 1D motion, which is what this whole video playlist is about, vectors can be negative or positive because usually 1D motion is along a line. So it's either going this way or this way, negative or positive. Here it's going up and down, same thing. Now I'm going to give you the mathematical definition of displacement. Consider an object's motion over a particular time interval. So let's say at the initial time, which we'll label as t1, the object's position was x1. At some later time, so we'll call that later time t2, the object has moved to a new position, x2. Then the displacement of our object is x2 minus x1, the change in x. And we denote this in physics with the Greek symbol delta, delta x. And delta just means change in. So change in. This means change in x. I'll give you an example. So here we have x and y. Say we want to find the displacement of an object and it traveled from 50 meters, which is our x1 position. And later, it moved all the way to 200 meters, which we'll label as x2. How do we find the displacement? And also, we're going to use vectors to represent this. So here's our beautiful arrow to represent our vector. Now let's find the displacement. Displacement is delta x, which is the final value. So final value minus the initial value. Here, the final value is 200 meters. 200 meters minus the first value, 50 meters. The displacement is 150 meters. Done. Here's a second example. Let's say you have a car, and your car, here's our car, it drives to the left from 200 meters to 50 meters. What is the displacement? So remember, displacement is x2 minus x1. Let's identify which position is x1 and which one's x2. x1 would be our first position, so our starting position, 200 meters. And it travels to 50 meters, which is our second position, x2. Let's find the displacement. So delta x is equal to x2 minus x1. x2 is 50 meters, x1 is 200 meters. So the displacement is negative 150 meters. So that's why our vector arrow is going to the left, because it's negative. And it makes sense because that's the opposite direction. Now I'll give you a quick challenge before we move on to the next example. If you were to walk 10 meters east, 5 meters west, and then another 20 meters east, what is your total distance traveled and your displacement? Hang on, let me clean up this 10 meters. It looks bad. Pause the video and figure it out. So your total distance is 10 plus 5 plus 20, which is 35 meters. That's how much you walked in total. Your displacement would be 10 minus 5, because you're walking backwards, plus 20, which is 25 meters east. In physics, it's important to give not just the magnitude, which is 25, but also the direction, so east, because displacement is a vector.